Hi guys, in this video I'll give an introduction to object-oriented programming, and I'll start out by demonstrating why classes and objects are important. So let's say we have an application where we want to represent cars, and a car could have a color. So let's say we have a blue car and it has horsepower, let's say 140, and there may be additional properties that represent a car. So defining a car with just primitive data types is challenging because they are loosely defined. They're just logically related, but in the code there's nothing that relates them together. Now, cars have properties such as color, horsepower, maybe make, model, and so on. But cars also have functionality, such as we can drive a car, we can turn left, we can turn right, we can brake. And this functionality would be represented by functions. For example, I just mentioned drive. And for each of these functions, we pass in the properties of the car. So with primitive data types, we would just pass in the color here, the horsepower, and anything else. So this makes it challenging because now we not only have the variables defined without being strongly related, but we also have the functionality, such as the functions here, spread out throughout our code. Nothing really encapsulates them that this is the functionality and the properties that define a car. Now, with classes, we can do exactly such a thing. So a class defines a blueprint of an object. And in C++, classes are defined with a class keyword followed by an identifier and then a code block. And the code block is really everything that belongs to this class. So here it's important at the end, don't forget the semicolon when you define a class. And then inside this code block, we define exactly what I just mentioned about. We define all the properties such as color, horsepower, and so on, what belongs to a class. And we define the functionality such as the drive function, brake function, turn left function, any function that is part of a car, of a real-world car. Now, properties are typically set to private. Without going too much into detail here, private means they can only be accessed within this code block, so only inside the class and only inside an object. Now I'm gonna show you in a little bit how this works. Actually, let me show it to you right now. Let's say I remove the code that I had before, and let's say we create an instance of the car. So I have car 1 here. Now car 1, you can see this is crossed out, color and horsepower. I cannot access it from outside. I can only access it when I'm inside the object here. Now, typically properties are private, and then we guard against the access with getter and setter methods. So set color, here I pass in the color, and then I can assign it, and then I do the same for the horsepower, set horsepower, and I can assign it to the horsepower. And now with this setter method, I can say set color, I pass in the color, let's say I want to have blue car, and this has horsepower 140. This will now get assigned to these two member variables. I don't go too much into detail about getter and setter functions. I have another video for this, but this gives us an idea of how this works. Now, earlier I talked about drive function, brake function, and so on. All this functionality will also be included here. So let's say we have a drive function. We don't need to pass anything in. Instead, we operate on the member variables here. We have them already, color and horsepower. So this could be as complex as you want to, but in this case, I'll just use a cout statement, and I access color, and I access the horsepower and a quick note. So here I have this car is driving, and let's say we have a turn left function, and I access the member variables again, color and horsepower with a quick note, and I add a turn right function. And I copy this from the left turn left function, which is pretty similar. So this gives me the functionality, or also called the behavior of the class, and this is the state or the member variables. So these functions operate on these variables. Now I could also pass in functions here. Let's say I have a degree, and let's say I use this here. So this is how we can pass something in, the degree. For example, the variables that I pass in that I just need in the function, but these are the variables that really define the object. So here this one is a class, so remember a class is really just a blueprint that represents really all cars. Any car that ever exists is represented by this template, by this blueprint. Now I create a very specific car here in the main, and this car, I call it car1, that's a variable, and it is blue, it has 140 horsepower, and now I want it to drive. So what I do is I do car1.drive. Next I want the car to turn left, so I do car1.turn left by 25 degrees. So this is kind of how we work with functions, with member functions. We don't pass the variable itself in. Instead, we call the function on the object, and the function then has access to these member variables, such as the color and horsepower. Now, this may become more clear when I create another car, another object, and I call this car2, and car2 will be green, and car2 is a little bit more powerful, let's say 200, and I also let car2 drive. So let's run this program and see what we get on the output. So at first we should see that car1 is driving, which is up here, which is blue 140 horsepower. Blue 140 horsepower is turning left by 25 degrees. And then the green car is driving. Now if I want my first car to drive again, I can say car1 turn right, for example. And if I run this, we'll see the turn right function here accesses the member variables of the first object. So each of these functions exactly operate on this object and only on the member variables and the values of that object. And this demonstrates that this up here is really just the template. When I create an object, each object has its own set of variables and its own set of member variables that get associated with that object. So here it has color and horsepower, which hold the values blue and 140, and car2 has again its own set of variables, color and horsepower, which get initialized to green and 200. And then these functions, they may operate on these member variables, but they don't have to. But the nice thing is here that we associate and encapsulate everything together, the state, the member variables, and the functions. And our code becomes much more readable and very clean what this really represents. So I hope this makes sense. Thank you for watching.